In this video, we'll be learning how to go about this question. So it's very straightforward. We have this equation, which is sine of x minus cosine of x equals 0. Due to the nature of this question, we can send the cosine of x to the other side to give us sine of x equals cosine of x. Okay. Due to the fact that we also have other trig functions, we can kind of manipulate this equation to get a simplified version of the second line we have, and we can do that by dividing through by cosine of x. And if we do that, the right hand side is going to give us 1, and the left hand side will give us sine of x divided by cosine of x, which is basically the same thing as the tangent of x. So we end up with tangent of x equals 1. Okay, and from here we can just take the tangent inverse of the right hand side, which is 1. That's going to give us 45 degrees. Okay, now we could have just ended here and concluded that is our answer, right? But I just want us to go further and see how you can actually derive other answers when you are given other conditions. Okay, so we know this as our Cartesian plane, and if we can remember this acronym called CAST, we use this acronym to help us to kind of remember which parts of the Cartesian plane or which quadrants of the Cartesian plane will give us positive values for each of the trigonometric functions. All right, so for example, if you take this quadrant, cosine of every angle over here is supposed to be positive, right? The next quadrant, for that quadrant, if you use the trig functions for any angle at that quadrant, you're supposed to get a positive number. For the third quadrant, if you take the sine of any angle which ends in that quadrant, you're supposed to get a positive number. And for the last quadrant, it is the tangent of the angle over there which gives you a positive number. Okay, so the acronym is CAST. You probably remember it from our high school or something. Okay, so we are going to apply this, right, to help us derive other angles in the case where you are given a different interval. Okay, we could have ended here based on the interval we were given, right? But I just want us to probe further, maybe probably to help you understand other concepts as well. So we have this Cartesian plane, right? Because this quadrant, right, where the all is written, because that quadrant, if you take the any trig function for any angle over there, you are supposed to get a positive number, and the tangent of x here is giving us 1, which is a positive number. It means tangent of x, it's possible that the tangent of x could be around this quadrant, or could be in this quadrant in the first place, because tangent of x is positive in this quadrant as well. In the same way, tangent of x is also positive in this quadrant. So we kind of have two possibilities, right, where the tangent of x is in this quadrant. Let's say this is the first quadrant, or tangent of x is in this quadrant. Let's call it the third quadrant, right? So if tangent of x is in the first quadrant, let's say this is our tangent of x, or the hypotenuse, right? So we can draw or get our y-axis and then label it as 1 and then 1, given that this is our angle x. Okay, so we can just draw this beautiful triangle for the first quadrant. Okay, and we can do the same thing for the third quadrant, that is this quadrant as well. Okay, so just the same thing, right, just that they are in different quadrants. Okay, so let's call the first one A and the second one B. Now we have two possibilities, or two possible values of x. Okay, so we are now going to try to read those values of x. Okay, we start by reading the values of x from the positive x-axis. Okay, so we start reading it from here, and it is read counterclockwise direction, or it is read in the anti-clockwise direction or the anti-clockwise direction. So we start from here and then we read it in this direction. Okay. All right. So we start from A. So from A, we're starting from here, which is 0. Then I'm moving till we get to this line, and from the question, x was from the solution we got over here, x is 45. So for the first diagram, we get x to be 45 degrees, which is what our answer is for this particular question. Okay, but for the second diagram, we have to start from 0 here and trace it all the way until we get to this line, this hypotenuse. Okay, so from here to here is 90. From here to here is another 90, so that gives us 180 if we start from here and then we move till we get to this part. Okay, once we have our 180, we move further again, which is 180 plus the x over here, right? And x is 45, and 180 plus 45 is going to give us 225. So basically we have two possible values of x, which is 45 and 225, right? But because of the interval we were given from the question, x is supposed to be from 0 to 180, right? And out of these two values of x, only the first one, which is 45 degrees, is between 0 and then 180 degrees. So we will state x as 45 degrees as our final answer. Okay, but if we're given a different interval, let's say from 0 to 360, because these two values, which is 45 and 225, are both within this range, then we would have stated those two values as our final answer. But as far as the interval we were given in the question is concerned, 45 is our final answer for this particular question. I hope you found this helpful in a way. Thank you for watching, and I will see you in my next video. Goodbye.